Welcome to Simple, Serious, Solvable with Chris Edwards, Climate Change 2023 program today. What a perfect day to sit cozy at home to meet with Chris Edwards' Zoom presentation on climate change. We know he is a familiar face to Detroit viewers, having served as chief meteorologist for Fox affiliate WJBK. This series serves as an excellent introduction to the facts and history, focusing on the science behind the topic and impacts localized to Southeast Michigan. Join us to explore the significant challenges we face and learn more about what each of us can do. And also, if you have any questions, please share through chat features or question answer feature. At the end of the presentation, Chris will answer all your questions. Now let us welcome Chris. All our patrons are eagerly waiting for your presentation, Chris, and thank you very much for doing this. Welcome. And now I'm going to mute, and I'm going to mute even video also, and you can just take over the stage.
Very good. Thank you. Thank you so much, Uma. I appreciate that. And thank you to everybody that has come to watch and listen for this evening. And as Uma mentioned, thankfully, you're able to stay cozy and warm and not slide around on the roads after we've had our most significant snow of the entire winter season today. Uma and I planned this months ago. We're incredible planners, so just keep that in mind, because we were very conscious of the fact that we wanted everybody to be comfortable and not have to go out into the elements, even though we planned this a long time ago. So kudos to you as well, Uma, for doing that. I do want to add just a little bit to what Uma said. Yes, indeed, I was on the airwaves here in the Metro Detroit area for actually a little more than 25 years, all told. I originally came here in 1989. But I think more important to the topic at hand is the fact that I have been studying climate change since all the way back in the mid-'80s, when it was most commonly referred to as the greenhouse effect, or sometimes it was called global warming. Now we generally tend to call it climate change, but it's all the same thing. It's just that in all those years since I started studying this, we've gone from something that is largely about theory and expectations to something that is unfolding and accelerating in front of us right now every day. You can't get away from news about climate change. And it seems like the perfect opportunity here in the early days of 2023 to begin talking with you and having a conversation, the first of two such meetings, when we can learn more about climate change and also learn that it is solvable and that there are things that we can do. And as much as I would love to spend the next hour maybe telling you a little bit about some amazing stories of my career in television and some really weird things that happened at times, truthfully, what we're going to go over tonight will teach you more and give you much more hope than any such stories of that regard. And I recognize as we start, I recognize that even the words climate change can be a little triggering to some people for a variety of different reasons. But I want you to know at the outset that when we finish and you've seen a lot of new information, you are going to leave with a concrete sense that this is solvable. It is not too late. Yes, it is serious. Yes, we don't have time to waste, but we can make a difference and we can make it happen. And that's part of what we will be talking about. And it's certainly the way that we will end this evening, along with your questions and hopefully my answers. So as we begin, I'll let you know, as Uma mentioned, we're going to see some slides and then I'll answer your questions. But the slides are put together in conjunction with both myself and the folks at Climate Central. And so I want to point that out, lower right part of the screen that you have there, that Climate Central logo. Now, Climate Central is maybe not a place you've heard of, but they are a policy neutral organization that is nonprofit. And they began all the way back in 2008. Their job is to report on climate science. And I've been working with their meteorologists since when they got started. Well, what's been now more than 14 years ago. What you'll see this evening is a presentation of facts, and the facts are derived from the latest scientific consensus, and that is what we will be talking about this evening. So to get us started, I'll let you know both the title and the gist of this presentation is that climate change is simple, meaning we understand the problem. It's serious, meaning that it's already impacting us and the impacts are accelerating. And it's solvable, as I already alluded, meaning we have the knowledge and the tools to avoid the worst impacts. And I'm going to tell you part by part in order why climate change is simple, serious, and solvable. And we start with simple because at core, I'm a simple kind of a guy, and I like to start with simple things. And simple, meaning we understand the problem, that's a great place to start. The basic idea of climate change is that humans burn fossil fuels, and by that I mean coal, oil, and natural gas. And this burning puts carbon dioxide, also CO2 is another name for it. So I might say carbon dioxide, I might say CO2, same thing. It puts CO2 into the atmosphere, and CO2 is a greenhouse gas. It makes the planet warmer. And that's probably the simplest way that you can explain it. But in a little more detail, let's talk about the atmosphere around us that encircles the Earth. And that atmosphere is primarily two different things. It's primarily nitrogen and a bit of oxygen. So it's about 99% if you combine those two things. Now, although other gases make up a small amount of the atmosphere, they have a very large role to play. And the gases I'm talking about are water vapor, carbon dioxide, methane, and nitrous oxide. We'll primarily be talking about numbers 2 and 3 here, although we'll certainly talk about water vapor as well. What these gases do is that they trap heat. They are greenhouse gases. And sometimes they're just referred to collectively as greenhouse gases. So this greenhouse effect, which I mentioned is what this whole change of the climate was referred to back in the 80s and 70s, the greenhouse effect is a very important part of the Earth. And here's an overview of how it works. In the top left, you see the sunshine. And it all starts with the sunshine. Sunlight from the sun and a lot of other energy reaches the Earth, even though that sun is about 93 million miles away. Now, as it reaches the Earth, some of that energy is reflected back into space. But it's also true that a significant amount of that energy is absorbed and then re-radiated as heat around the globe. This is what the greenhouse effect is. The greenhouse gases absorb and re-radiate that heat, and it's a really good thing that it does. It makes the planet, this effect makes the planet livable. As it is now, the average temperature Fahrenheit around the whole world is about 60 degrees. That number has been going up, of course, but that's about where it is. If we didn't have the greenhouse effect, the average temperature of the Earth would be about 0 degrees Fahrenheit. So imagine that. Our lives would be extremely different. And slight changes in those greenhouse gas concentrations can alter the climate, and that affects the world around us. That is the important part about the greenhouse effect, that heat absorbed by the greenhouse gases and re-radiated makes the planet livable. Well, here's something you may not have heard before. The greenhouse effect is something we've known about for a long time. As a matter of fact, the link between climate change and CO2 is at least 200 years old. Back in the 1820s, that guy on the far left, Joseph Fourier from France, he proposed that there were gases in the atmosphere that was keeping the Earth warmer than it would be without them. This is 200 years ago, he proposed that. Then in the 1850s, Eunice Foote, a female scientist from our country, was the one who discovered that greenhouse gas, specifically carbon dioxide, warms the air all around it. And that's amazing for so many reasons. But I have to stop very briefly and just give a major shout out to women in science. Here is a woman that in the 1850s was making huge contributions to science, and it was going to be 70 years before her gender could even vote. It is incredible what women have done in science and what they continue to do in science. And every time I can, I want to encourage women to seek out science and to be scientists and to go into those kinds of fields. I guess our own daughter was listening. She is now a molecular biologist out in Seattle, and she is working on trying to cure pediatric tumors and cancer. So she got the message during the course of growing up, but I hope all young women can get the message that they make tremendous contributions, as Eunice Foote did back in the 1850s. Now we move on to the next guy, though, Svante Arrhenius from Sweden. He actually calculated that a doubling of carbon dioxide in the atmosphere would raise the Earth's temperature by several degrees, and that was in the 1890s. And then in the 1930s, that guy on the far right, Callender from England, he refined Arrhenius's calculations, and he made the first climate projections way before we had computers, and he assembled the first evidence of global warming. As a matter of fact, his work was so important that many climate scientists call this whole effect the Callender effect, because he was the one that really put the pieces together. And speaking of those pieces, here's the deal. Carbon dioxide plays a critical role in regulating the temperature of our planet. And in the 1800s, we started burning a lot more fossil fuels, particularly the second half of that century. First coal, then oil and natural gas. Now, these fuels powered the Industrial Revolution, which without a doubt, that raised the living standard of millions of people around the world in the more advanced countries, of course. But they also increased the amount of carbon dioxide in the atmosphere. So if Callender and the others before him were correct, we should see temperatures rise as CO2 increases. Well, that was the theory. Let's look at the facts. This is a graph of carbon dioxide in parts per million in the atmosphere, going back on the left side to about 1880. And then you see this slowly but steadily rises through the early to first half of the 1900s. And then it really went on a more significant path upward to where the very latest readings of carbon dioxide parts per million in the atmosphere are right around 413, fully 50% higher than in pre-industrial times. About 413. Give that a little more perspective in a bit. But so, okay, that's what CO2 did. So what did temperature do? Well, there you go. The key point, as the CO2 is increasing, it's causing the planet to warm. And although the two are not lockstep throughout the entire time frame, there is no doubt about the link between the two, and even the acceleration in the carbon dioxide in the air is going along with an acceleration in the temperature increase as we look at the last 140 years approximately. So I want to back it up a little bit farther, not just look at 140 years of carbon dioxide levels in the atmosphere. We go back 800,000 years. And very briefly, we know this because of ice core samples that we're able to take. But when we go back 800,000 years, we don't see carbon dioxide levels anywhere close to what we have today. And as you can clearly see for yourself, not only have we gone higher than in almost a million years, but we've gone much higher extremely quickly in the overall scope of time. So carbon dioxide does vary naturally as part of glacial cycles, and that's part of what we're seeing here. These glacial cycles changed carbon dioxide and changed our temperature, but they did so over a long period of time, and they never went nearly as high as what we see now. Some studies suggest that we are at the highest levels that we've seen in 2 million years, but for now, we'll keep it to 800,000 because clearly our planet had a whole lot less human civilization 800,000 years ago than what it does now. I want to give a little bit of attention here to methane, which you may have heard a little bit more in the news lately with good reason. But methane is one of those greenhouse gases I talked about at the beginning, and it's a very important greenhouse gas. And it too, as you can see, this is a shorter time scale, only about 40 years or so. But over that 40-year time, the levels of methane in the atmosphere have gone up quite considerably. Now, methane is a very potent greenhouse gas. The bad news about methane is that molecule for molecule, it's a huge amount more, multiple times more effective at trapping heat. In other words, it's multiple times worse in terms of its potency as a greenhouse gas. The good news is that methane breaks down in the atmosphere in about 10 to 12 years. So if we can get methane out of the atmosphere, we can stop pumping the methane into the atmosphere, in 10 or 12 years, it'll be gone and it will no longer be a factor. Unfortunately, CO2 takes a lot longer to come out of the atmosphere. We're talking hundreds of years. But you can kind of look at methane. If you start to look at what we do about this, methane is sort of like the low-hanging fruit. If we can do that and stop the introduction of methane into the atmosphere, it buys us time. And at this point, that's something that we could use. So let's step back for just a moment on this snowy winter evening and bring this to Detroit, bring this to the Metro Detroit area, and see how we here in this small, teeny little corner of the world have changed since the 70s in terms of temperature. And on the far left, you can see average temperature in the 70s, the whole decade put together, was about 48.5 degrees Fahrenheit. And it went up modestly in the 80s, but it really took a big jump into the decade of the 90s. Stayed relatively static, just a slight increase in the aughts or the 2000-2010 range. And then in the 2010s, it took another big jump to where we are now fully 3 degrees Fahrenheit warmer on average here in Metro Detroit than what we were in the 70s. So for those of you who might have grown up around here, have recollections of the 70s, that it was some earlier time in your life, and you sometimes think, wow, it seemed like we got more snow and it was colder here when I was young. It isn't all your imagination. There is definitely some truth to that. And this is just one small point in the entire globe. If we were to look at cities all over the world, some would have warmed faster, some more slowly. And warming is just one of the things that's changed, but warming is certainly one that is easily felt. Different way to look at this then is by looking at the warming by season. And again, this is the Metro Detroit area. This is over the last 30 years or so. So the question that this seeks to answer is, what season has warmed the most here in Metro Detroit? And the answer, clearly in blue on the left, is the season we're right in the middle of right now, and that's winter. Winter has warmed, on average, in Metro Detroit more than any other season. Spring, quite a bit less. Summer, pretty modestly, and fall also quite a bit. Now, this may square with your own perceptions and your own recollections, or it may not, but this is what the data shows, and this is what the facts are. And as I said at the beginning, that's what we're dealing with, and that's a little localization from a global perspective right down to our backyard's perspective. All right. We know that CO2 affects temperature, just talked about that. We can use that knowledge, though, to look at the future. And the important thing that climate scientists use, these sophisticated computer models, which get better and better all the time, predict how Earth will respond to rising CO2. Earlier versions of these models that I started looking at closely in the 1980s predicted our recent warming. Now, the models tell us two things. The amount of warming depends on future carbon emissions. That's really important. So lots of carbon emissions in the future lead to lots of warming. This path here in the red, which quite frankly is rather frightening by the end of the century. However, on a positive note, the bluer path here, if we reduce emissions, temperatures stabilize. The longer we wait, the worse it gets. The divergence of these two paths has to do with what we do from this point forward, not what we've done in the past. So there's the simple part, and I hope that was relatively simple. Let's move now on to the serious part, because there are consequences to what's going on and to what will happen. You see, warming is leading to other changes in the atmosphere. It isn't just about warmer conditions, which is one of the things we'll talk about. We're already seeing warming lead to wilder weather and rising seas, and we'll take those things one at a time. First of all, really important to understand, as this graph shows us in motion here, that while we're talking about averages, because that's the way climate works, we talk about these averages, we have to recognize that small shifts in average temperature can lead to large increases in extremes. So on the right here, as we shift the average over, we get a lot more significant heat and considerably more extreme heat here in the bottom right. Now, on the flip side, that means less extreme cold and less serious cold. An important note here, it doesn't mean no extreme cold. It doesn't mean no cold at all. It means it's not as much as it used to be, because small shifts in the averages lead to extreme events and reductions in the amount of extreme cold. So something else that I mentioned was the wild weather and the wild weather events. Now, one of the ways for many decades that weather and climate scientists have measured impact on society is by damage from extreme weather events. And particularly, they've had this line in the sand, if you will, of billion-dollar weather events. That is an extreme weather occurrence that produced at least $1 billion in damage. So that's kind of an arbitrary number that says, well, this was a biggie. Okay, and we track how many such billion-dollar events happen each year. And the long-term average in our country of billion-dollar weather events is about 7, going back a whole lot of years. And by the way, important note right off the bat here, these are inflation-adjusted dollars, so they're consistent dollars. So those events, on average, about 7 if you go back about 100 years or so. What has been happening lately? Well, for the first time in 2011, we had 16 events like that. Then we had some quieter years. Then in 2017, again, we had 16 such events. And look at the numbers of what we've seen lately. We plotted up 2020, so 2 years ago, when we were all understandably extremely distracted by a pandemic. We happened to also have $22 billion weather disasters. And 7 of those in this country were tied to landfalling hurricanes. So if we didn't have enough to deal with in 2020, we had a record number of such events that year. And then the next year, in 2021, we had 20 of them, including 2 historic severe weather events in December in the Ohio Valley that led to large loss of life. We'd never seen anything like that before, but that's what we saw in 2021. And although we haven't had time to plot it on the graphic yet, we just wrapped up 2022. And I will tell you that in 2022, last year, we had $18 billion disasters. So the line's going to end up right about here on the right side. $18 billion disasters. And Ian alone, that hurricane that hit Southwest Florida in late September, that hurricane alone caused $113 billion in damage, not to even mention the extremely tragic loss of life that came along with that, even though Ian was a very well forecast and a storm for which we had a lot of preparation that was able to happen. So when people say, rightly so, that making changes that we need to make is going to involve a significant investment of money, because it is, know that the path we're on is also extremely costly, even just in dollars and cents, which this certainly shows us. Now, back to Detroit for just a brief moment. I like to show this slide briefly, and I have to give you a little idea, help you understand what it is that it's showing us here. These are decades going back to the 1870s, and in each decade, you have a certain number of record high temperatures, and you have a certain number of record low temperatures over a 10-year period. The record high temperatures are shown by this red or orange bar, and the record lows are shown by this blue bar. Here we go, as we go from the longest time ago to the most recent time, from left to right. So you can see that for many, many decades, we had far more record highs than record lows, all the way through the 40s and the 50s. But something kind of interesting in Metro Detroit happened in the 60s, 70s, and 80s. We actually had more record cold days in the 60s, 70s, and 80s here than we did record heat. Well, the reasons for that are varied, and we don't have really time to go into them. But again, it speaks a little bit to the fact that perhaps if that was part of your youth and Metro Detroit or Southeast Michigan was part of your youth, you might have some recollections of things being colder. They were actually unusually chilly in a lot of ways during those decades. But that is a thing of the past, because look at the last 3 decades, starting with the 90s and then the aughts and the 2010s. We are smashing the number of record highs compared to record lows. It's roughly a 4-to-1 ratio now. It's not even close. And this is just one spot on the Earth. Keep in mind that globally, for the whole Earth now, if we spread it out to that, because we are talking about global climate change, 10 of the last 11 years, 10 of those years have been the warmest 10 years ever recorded. So there is no doubt about what is going on, especially in the more recent past, because globally, those warmest years on record have all happened since 2011, which to me is just kind of mind-boggling, even if you might have some different perceptions of what has happened here. So this evening, with the snowfall we've had today, good time to talk about how snowfall patterns change, because it is true that milder climates are getting less snow. because temperatures are more commonly above freezing. Now, late fall and early spring can lead to a decline in snow in a lot of locations, but cold climates like ours, and we have to consider ours a cold continental climate, where temperatures are still often below freezing in the winter, we can actually get more snow. And part of the reason for that is that there's more moisture in the atmosphere than in decades past. We'll talk more about that in a couple minutes, but we can get more snow. So when a heavy snow happens, that is not a reason for somebody to snicker and look at that and say, yes, so much for climate change. Indeed, climate change theory shows us that individual snowfall events can actually be heavier than they used to be because a warmer atmosphere holds more moisture. So that is not a sign that climate change isn't happening. Indeed, it's sort of a reinforcer and something that we have expected to happen, and in many cases we are seeing happen. And it's also worth noting, we are in the Great Lakes. We don't have mountains around here, but in many mountain locations, especially the western part of our country, more of the winter precipitation is falling as rain. And that's not a good thing, because water as a resource is stored as a snowpack out west. And if it falls as rain instead, it tends to run off more quickly and more of it gets wasted. So that's not a really good regional change to weather patterns. And speaking of snow that sticks around for a while, on the left, you have a glacier in 2012. On the right, you have an aerial picture of the same glacier 7 short years later. Now, ladies and gentlemen, I could show you pictures from all over the world, North Pole, South Pole, high mountain ranges, even tropical regions, Mount Kilimanjaro, surrounding regions to that, where glaciers have retreated and retreated quickly. I don't have time, and you probably don't have interest in seeing all those pictures, although some of them are stunning. The important point here is that warming is melting glaciers very quickly, and the northernmost regions, or indeed the more polar regions, which is North Pole and South Pole, they are warming much, much faster than the latitudes where most of us live. In fact, it's estimated overall that the Arctic is warming 2 to 3 times faster than what we are here. You think about what you've noticed here already, but the Arctic is warming much faster than that. And the populations of people that live there and have for millennia are having to deal with incredible rates of change that are really hard to even get your arms around. And that may be, if we don't take the proper action, the sort of course that we are on. Now, by the way, these pictures are of the Bear Glacier, which is in Alaska, south central Alaska, specifically in the Kenai Fjords National Park, a beautiful area that I've been fortunate enough to go at one time in my life, but I know that when I go back, it's going to look very different than what it did years ago when I was there. So I'll take a little breath, and as I do that, and I'll take a little sip of something to drink, because I want you to absorb this a little. First of all, I'll give you a little orientation to what this is. These are ocean temperatures, what we're focusing on here in these colors. The black is land. That's not what we're focusing on right now. We're talking about the change in sea surface temperature in about the last 120 years. And wherever you see red or brown or orange, a color of that nature, that is where sea temperatures have gone up. And the darker the color, the more they've gone up in that 120 years. Because indeed, most of the extra heat that we've added to the Earth has not gone onto land. More than 90% of it has been absorbed by the ocean waters. So you can see tremendous amounts of warming all over the globe. But I want you to look very closely at this map and see if anything sort of jumps out a little bit. Hint, hint here, look a little bit for some blue that's not an ocean color, but blue that is near the top of the map range. And I know, unfortunately, that you can't raise your hands and tell me that you've spotted it, but that's okay, because I will point it out to you. This area right in here, and that is colder ocean water, significantly colder, and it shows up year after year after year. And you might look at that and say, well, I guess perhaps global warming isn't happening everywhere. That's a different story, by the way, but that's not the case here. What is going on, as some of you may have guessed, is that colder water is right south of Greenland, the continent of Greenland, that I'm kind of encircling with the red dot. And what's on Greenland? Well, Greenland has been covered by glaciers for a very, very long time, ice. And that ice is melting and melting quickly. I just talked to you about how much more quickly the Arctic regions are warming. And those glaciers are pouring immense amounts of cold water into the North Atlantic, and they're doing it year after year after year, particularly in the Northern Hemisphere summer, but not just in the Northern Hemisphere summer. So you might look at that and say, oh, well, that's interesting. Well, here's why it's more than interesting. Patterns of weather are driven primarily by ocean currents. So the ocean currents are what drive the weather patterns. The weather patterns are what drive our storms. They are what make our climate, our weather that changes day to day and our climate that changes more slowly. The Gulf Stream, for a long, long time, has ridden up the east coast of the United States, moving from southwest to northeast, and then gone up near the Labrador Current area here as well, and then gone up to the North Atlantic up in here. Well, now this Gulf Stream is now encountering a massive, consistent patch of colder, less salty water than what used to be there, and it is disrupting weather patterns, particularly those that affect Western Europe. So what's going to happen to the weather patterns in Western Europe as this continues? We don't really know, unfortunately. This is one of those times when I will tell you the facts when we know them, and I will not posit theories that are untested if we don't. And the truth of the matter is, we're sort of doing this experiment with the planet, and we're going to see over the coming years and decades how the weather patterns change. We don't know how they're going to. We know that this is likely to persist, and scientists have known about it long enough that they've assigned a fancy, difficult to pronounce name to it. This one is called the Atlantic Meridional Oceanic Circulation, or AMOC for short. But despite that name that global scientists have put on that, the most important point is that we don't know how that's going to impact us, or particularly those in Western Europe, but you can bet that there are millions and millions of people that are watching extremely closely, and we're going to have to see how it plays out over the years ahead. So let's then talk a little bit more about sea level, because sea level rise is something that we've really seen. But this is a 2,000-year graph. This is basically each little bar represents 100 years. And we'll go back to essentially 1 AD, roughly 2,000 years ago. What in that 100 years did sea level do? It went up less than an inch. And then in the next century, it went up about 1.25 inches. And then the next century, it basically didn't move. So you've seen these small moves up and down, but small moves, all of them, in sea level over the course of most of the last 2,000 years. And then look what happens in the last 100 years. Whoop. And that is extremely unusual over that 2,000-year period. What's going on? Well, it isn't so much the melting glaciers I talked about before from Greenland and other places. It's actually a much bigger factor that warm water takes up more space. And when we heat up the ocean waters more, they take up more space. And when the water takes up more space, the sea level rises, and that is what's going on. Sea level over the last 100 years has seen an unprecedented rise compared to the previous 19 centuries. And all projections are that this is likely to continue. So what does that mean for us in Southeast Michigan? Well, as you might have guessed, not a whole lot. But we should remember that tens of millions of people around the world, if not hundreds of millions, live within a few feet of sea level. And so as the sea level rises, you get more flooding. Higher tides make for more flooding. And this is a graph of, in the US, of the amount of flood days that we've had, starting in the 70s when there were around 11, and now that number has essentially doubled as of the most recent data. Even without storms, places, particularly South Florida, but there are many other places on the East Coast where they have what they call sunny day flooding. They have different names for it, but not too many of them are good, where even without a storm, there's flooding because the sea level at high tide is much higher than it used to be. A few inches may not seem like much, but they make a significant difference from day to day, which leads me to another really important point that I touched on a bit earlier. And that is, when we talk about warming, it isn't just warming. It's what else happens with the atmosphere when there is warming. One of the most important things to know about climate change is that relationship between temperature and the amount of water vapor in the air. So a warmer atmosphere holds more water vapor. So let's think about that for a moment. Why does it feel more humid in the summer? Well, that's because the warmer summer air can hold more moisture, and it does hold more moisture. So we feel humid in the summer where we very rarely feel humid in the winter. An increase in temperature allows more evaporation into the atmosphere from oceans, lakes, even soil and plants. Provide some of the moisture into the atmosphere. So there's more water than available for potential storms. And remember, most of the globe is water. I showed you that other map. Almost 75% of the planet is water. So more of that water can go into the atmosphere. As this graphic shows us, for every 1 degree increase Fahrenheit of temperature, you can hold 4% more water vapor in the air. So what this does is it supercharges the water cycle. It increases the amount of rain and snow in heavy precipitation events, but also, and this is a little counterintuitive, it also leads to larger and longer droughts because you have a warmer temperature. And if there's no trigger to squeeze the moisture out of the atmosphere, it doesn't rain or snow. It just heats and dries up more quickly. So one of the things, if you pay attention to the news of climate change, you'll hear heavier rain and longer drought. And you might think, well, how can that possibly happen? It's really pretty simple physics of how the atmosphere holds moisture and whether or not it's around to evaporate or precipitate. The key message here, though, is that wet areas and wet seasons are getting wetter, and dry areas and dry regions and seasons are getting drier. So there's increased potential for extremes in both those directions. And we've seen that in regional data around the country. Focusing on our area, we're in this Great Lakes region where we've seen in about the last 60 years or so, we've seen a 42% increase in heavy rain during heavy precipitation events. They've seen a little bit even more than that in the northeastern US and lesser amounts generally in the West. But the supercharged cycle, that water cycle that I was talking about, is part of what's going on there. Now, wetland loss and development has also made flooding more likely, no doubt about it. More development, less natural percolation, you pave more, you're going to get more flooding. That is absolutely a part of it. But in addition to that, the actual rainfall rates have been heavier as well, and we're continuing to see that. And how do we see that play out here in Metro Detroit? Well, here's a graph for us over the last 50 years. And the gist of it here is that when it's raining, it tends to rain at a harder rate. That's rain or snow, by the way. When it does rain, it tends to rain at a higher rate than it did even just 50 years ago. And this is playing out in some very significant ways. The Clinton-Macomb township area maybe has not been hit quite as hard as some other parts of the metro region over the last 8 to 10 years, but there have been some horrendous flooding events. And the most recent really bad one was back in June of 2021, when right on the city of Detroit Grosse Pointe border, there was 8.2 inches of rain in less than 24 hours. Those are unheard of rainfall amounts, and they led to horrendous flooding. There is not a municipal water system that can handle that kind of flow. And unfortunately, every summer, we see areas in our country, not to mention other parts of the world, where they're dealing with flooding that causes horrendous loss of life and property damage of the likes they have not seen before, because the supercharged water cycle is a real thing. Even just this summer, maybe it didn't hit your brainwaves because you had a lot else going on, but there were millions of hectares or acres of land in Pakistan that were underwater, and literally thousands of people lost their lives because of the flooding in Pakistan, the likes of which they haven't seen before. We're seeing it in many different parts of the world. So a brief moment here that I'm going to devote to hurricanes and climate change, because in the wake of Ian a couple of months ago, I was watching a lot of news and consuming a lot of information to see what was being said out there. And there was something that was not factual that I heard often repeated. And it essentially went like this: with climate change, we can expect to see more hurricanes. Okay, it was something very close to that. With climate change, more hurricanes. I can tell you here, because I promised you a presentation of facts, that that is not what the data supports. It's not what the research shows. We are not expecting more hurricanes because of climate change. However, What we do expect, and what we have already seen, is that as the ocean temperatures warm, which they clearly have, the hurricanes that do form have a tendency to be stronger, and they can be more powerful storms, and they can last longer. So the news is not all good by any means, because the water is warmer, and warm water is the main fuel for hurricanes. But it's just that there aren't necessarily going to be more of them. The latest research shows that it will probably be essentially the same number, or maybe even a slightly smaller number of actual hurricanes. But the ones that hit not only tend to be stronger and move more slowly, but they have a greater likelihood. This is recent, very interesting research, that these hurricanes have a greater likelihood of doing rapid intensification just before landfall. Now, that's a very bad thing for civilized areas. Unfortunately, we saw it with Ian. It rapidly intensified soon before landfall, and it was a powerful hurricane that did not move very quickly. So think about that. Research showing that hurricanes move more slowly is not good, because if you have a devastating hurricane that's moving through an area, would you rather it move through at 5 to 10 miles an hour or at 25 miles per hour? I mean, I, for one, would rather it get in and get out. I want it to be like my crazy uncle. If he has to visit, make it short, get out of here, okay? Because hurricanes tend to move more slowly, they have the potential to do more damage just for that reason. So that's a couple of words about hurricanes. If you have further questions, we can talk about that in questions and answers. But the drought, the flip side, is that evaporation happens more over land. This can make dry areas drier, and we're seeing an increase in extreme droughts, particularly in the Western US. This graphic is showing us the longer and more frequently we see these brown lines, the worse drought is. This is going all the way back to 1900, when drought in the West was not that common. Well, it would happen sometimes, but not that commonly. Sorry about that advance. But you see, as we go through time, the 60s, 80s, 90s, we've seen more and more drought. In fact, the Western United States is in the midst of its worst drought in 1,200 years. Now, the last month has put a massive dent in that drought, as one storm system after another has dropped huge amounts of moisture out there. But it hasn't put an end to it, because it's a very, very long-lasting drought. And so we're not necessarily ready to say the drought is over, but what we are seeing is a whole lot more variation, more of these extremes again. Just like we've seen the Great Lakes go from very high levels and drop more quickly than we've ever seen. That's what's happened over the last couple of years around here. Out west, worst drought in 1,200 years. And what has happened to the snowpack in the Sierras of California just in the last month? Well, they've gone from drought to the highest snowpack in mid-January that they've ever recorded. Again, more in the way of extremes, of both positive and negative, heavy and light, warm and cold. So some other elements of serious are important to talk about, because we've got wilder weather and rising seas and things like that. But climate change also changes the nature of the whole world around us, our health, our economy. They are all impacted. Now, these impacts of extreme weather are some of the things we've talked about. I've already discussed more extreme and longer lasting heat, heavier downpours, more intense drought. I didn't talk about it much, but wildfires are more common. And unfortunately, the wildfires lead to more pollution. They are more common, and stronger, more rapidly intensifying hurricanes. But there are other impacts. Remember, we are just one species on the planet. There are many, many others. And what we're seeing with climate change is massive impact in the natural world. Animals and plants are used to adapting, but what we're asking them to do is to adapt extremely quickly, far more quickly, by orders of magnitude more quickly than they've ever had to adapt in the past. As the climate warms, many of these species are moving north where they can, or poleward, or they're moving to higher elevations. If they can move up, they will do that if they can. Now, in some cases they do that, and in some cases they can't. We are seeing seasonal cycles disrupted, with plants now blooming earlier in the spring than what they used to, and that creates a mismatch between predators and the prey. So some ecosystems, though, like coral reefs, there's nowhere for coral to go. They're particularly sensitive to water temperature increases, and they've been severely impacted by warming ocean temperatures, heat waves in the ocean already. And there's been a great decline in those. Unfortunately, that's, excuse me, that's also continuing. So how about our health? Well, we are seeing some degradation in our health because of climate change. Warm conditions make air pollution worse. Climate change amplifies, as I mentioned, the wildfires, for instance. Other sources, burning coal and diesel, there are CO2 sources, but also wildfires are. The heat impacts us directly, though. Increasing days where physical activity outside is just plain dangerous, especially important for people that work outdoors and for athletes. We also see that mosquito and tick-borne diseases like Zika, malaria, Lyme, they are spreading into new locations and they're sticking around longer. And longer allergy seasons are being witnessed, more asthma and hay fever. Higher CO2 levels even make for more poison ivy over a more widespread area and makes it more irritating in many cases. And of course, our food and farming and agriculture are being impacted. It impacts how we produce food and the people that are working on the farms. Wild weather events, as you can imagine, like flooding and drought, have an enormous impact on crops and farmland, but planting zones are shifting farther northward or poleward. I just read an in-depth article a couple of weeks ago about how world-famous Colombian coffee, in a few more decades, if things don't change, they won't be able to grow coffee in Colombia anymore. They're moving up the mountains as quickly as they can to plant higher up where it's cooler, but they're going to run out of mountain. And then Colombian coffee might be a thing of the past. I don't know if you're really tied to your coffee, but many people are, and just the thought of something like that happening can be a little disruptive in some people's minds. Not to mention the fact that crop diseases and pests are spreading and sticking around longer in many different areas. So that's enough about the serious. This is my favorite part. So I can take a little breath and you can all take a breath, because we've gotten through the simple and we've gotten through the serious. And now we get to talk about solvable, because it won't be easy, but we can do it. And that's part of what I want to talk about for the next few minutes, because you may have heard a target. I hear this bounced around a lot. This target of let's stay below 1.5 degrees. Now, first of all, that's Celsius, not Fahrenheit. And most of us aren't too used to working in Celsius. So 1.5 degrees Celsius is about 3 degrees Fahrenheit. So keep that in mind. But however you express the target, we need to reduce carbon dioxide emissions and methane quickly and drastically. That's going to make the difference. If we don't, then we're on this red path, headed toward 4 degrees Celsius of warming, which is about 8 degrees Fahrenheit, which is just about unimaginable by the end of the century if we continue on our present path. By the way, how much have we warmed so far? About 1 degree Celsius, or about 2 degrees Fahrenheit is what we have warmed so far. A little more, a little less, depending on exactly how you measure it, but somewhere in there. But the good news is that if we stabilize the greenhouse gas emissions by 2050, seems like a long time away, but it's not. If we stabilize by 2050, we can start to get into this zone, because we need to not only reduce emissions quickly, we also have potential to remove some of the greenhouse gases from the atmosphere that are already there. And those are a couple of the key ways that we talk about making change. So in order to understand how we make change, we got to start at where we are. And here is a pie chart that shows where our emissions come from in this country. Obviously, it's different in different parts of the world, but so how do we do it? We need to lower greenhouse gas emissions. And in the US, those emissions largely come from transportation and electricity. Those two things together make up almost 60% of the greenhouse gases. And we'll talk about each of these individually. There are other sources: industry, commercial and residential, even agriculture. Culture is 10% of the emissions that we put into the atmosphere. But we already have solutions to reduce emissions from each of these sectors, and we'll go through them in kind. Let's start with renewable energy, which does get a lot of attention, sometimes called clean energy. I want to call it renewable energy. On the left, this is where the sun shines in this country. The darker the shade, the more sunshine available during the course of the year. And as you can see, and probably would expect, the southwestern part of the country gets the most sunshine. But even here in our part of the world, the Great Lakes, where it seems like we haven't seen the sun here in about 6 weeks, but we do get plenty of solar energy even in our part of the world. And as the cost of solar energy decreases, it becomes more and more possible to harness even the energy that we get in our part of the country. And then on the right side of the screen in the blue, this is where the wind blows. And the darker the shading here, the more wind there is. And that's primarily the Eastern Rocky Mountains and the Western High Plains. Those are tremendous sources of wind energy potential in those areas. We're already doing a lot of that. We've already seen huge decreases in the cost of these renewable energy sources. In fact, over the last 10 years, solar power is down almost 90%. It's bounced a little in the last couple of years, but down almost 90%. And wind energy is about 70% lower in cost than what it used to be. So something else we can do, electrify transport. One of the most important steps is moving ourselves from one place to another puts a lot of greenhouse gas into the atmosphere. So we need to change the way we do that. We need to convert cars, buses, trains, and other modes of transportation from internal combustion engines to running on clean electricity, electric vehicles that are getting better and cheaper every year, more prolific every year, and battery capacity is growing. We're solving more and more of these challenges. There are more places to charge them. This is one of those chicken or the egg things. People say, well, I'd get an EV, but there's not enough places to charge them. And there's a hesitancy to install so many of the charging places because there aren't enough EVs to support them. Again, chicken or the egg. We're making progress on that, and it's going to really change a lot, I think, over especially the next 5 to 10 years. But EVs are simpler to maintain, and some of the companies in Southeast Michigan, some of the big employers that have such a long history here, I'm talking GM, I'm talking Ford. GM is not just PR. They have made a commitment to have an all EV fleet by 2035 model year. That's not very far away. And to be carbon neutral as a company by 2040. That is a real commitment. And Ford has made similar commitments as well. And by the way, very briefly, what does carbon neutral mean? You hear that tossed around sometimes. Carbon neutral, whether it's a person or a municipality or a country or a company, it means that a certain amount of greenhouse gases are emitted and a certain amount are pulled out of the atmosphere. If those two come together, if you pull out as much as you put in, you're carbon neutral. And that's what GM has committed to being as a company by 2040. And that is not just PR. But we should remember, too, that we use a lot of energy to heat and cool our buildings, and architecture and building design can increase energy efficiency immensely and require less energy for day-to-day operations. Simple things like improving insulation saves money and energy and increases comfort. And electric heat pumps, you may not have heard about them yet, but you're going to hear about them in the months and years ahead. I just saw a report just today that I believe it's Finland, either Norway or Finland, one of the Scandinavian countries, is now almost 2/3 heating themselves on heat pumps. Some people say, you may have not even heard of a heat pump, but some people say, well, you can't use a heat pump to keep you warm in a cold climate. Hey, Finland and Norway are cold climates. They work. They are more expensive at the outset, but over time, they save money because you're not using the coal, oil, or natural gas in order to heat a building. Instead, you're using a heat pump, which doesn't use those things. They can run on electricity. And we can reduce emissions in a big way through changing our farming practices, which a lot of farmers in Michigan are doing. They're creating better crops at the same time, better agricultural practices, lower methane emissions, and that's very important. It's another potent greenhouse gas I talked about. Whether it's rice farming or raising sheep and cows, that can produce methane. We can do things differently and reduce the amount of methane which goes into the atmosphere. And increasingly, we're realizing that a lot more methane than we thought is part of the puzzle. So we need to reduce the tilling and the planting cover so it can keep carbon and water and important nutrients in the soils. And composting food waste helps reduce methane emissions from landfills and recycles fertilizer right back to the crops. It's also important to I mentioned taking carbon dioxide out of the atmosphere. One of the ways that we can do that naturally is with plant tissue, because productive ecosystems like grasslands, wetlands, peatlands, they accumulate carbon in the soil and plants. So if we maintain and protect those areas from development, we prevent carbon from entering the atmosphere to begin with, and it also helps to absorb and filter floodwaters, which is a big deal. Coastal wetlands have a huge role to play in reducing the flooding of things like hurricanes. And the power of trees. Back to Metro Detroit specifically. just in our area. These are some pretty big numbers and hard for me to put into perspective. I don't know about you. When you talk about almost 2 million tons of CO2 equivalent removed, that sounds like a massive number. It is, but I don't really know how to compare it easily for you. What I can tell you is that a lot of storm runoff is taken up by trees that are in the Detroit area, and a lot of air pollution is absorbed. And clearly that message is getting through, not only in different parts of the world, but even locally. The city of Detroit last fall launched a program in October to plant 75,000 trees in the next 5 years by the year 2027. That's a commitment which has already been started. Trees are in the ground, and they'll continue to be put in the ground in the warm season for the next few years to the tune of 75,000 just in the city of Detroit. Is this going to solve all our problems? No. There are many pieces to this, but that is one. And I love the proverb, which is called a Chinese proverb. Perhaps it is, perhaps it isn't, but it's wisdom. And the wisdom goes, when is the very best time to plant a tree? 20 years ago. When is the next best time to plant a tree? Today, or when it warms up a little and the ground thaws. You get the idea. We can't do anything about a tree or a change that we didn't take care of 20 years ago, but we can moving forward, and it starts to make a big difference. And speaking of a difference, as I get ready to wrap up the slides and open it up to your questions, I have to make a couple of really important points. Probably the most important is that to stay close to that 3-degree Fahrenheit warming, we need to make big changes, and we need to do them quickly. We have squandered time, so we no longer have the luxury of time. But we've made big changes in the past. Anybody that says we can't do it, it can't be done, on the far left there, this is a not particularly pretty picture that shows us indoor plumbing. Indoor plumbing and electricity radically changed daily life and made cities so much safer. Within a generation, it basically doubled life expectancy when you had indoor plumbing and you had sanitation and electricity. All those things made massive differences, and people said it can't be done, but we did it. The middle slide, the space age. We ushered in new technologies and computing advances that we continue to use now, even satellites to help us understand the environment better and the world that's changing around us. Huge changes. When President Kennedy in the early 60s said, we're going to go to the moon, not because it's easy, but because it's hard. A lot of people thought that was ridiculous. There was no way we could get to the moon and back within that decade. Well, we did it. And people said it couldn't be done. And on the far right, how about the internet, mobile phones? Do you realize that 15 years ago, the first iPhone came out? In less than a generation, radical change has come to hundreds of millions of people around the world. It's the internet age, mobile phones, transformative. In just a few decades, instant communication over vast distances that our ancestors could never even have imagined. And people said we couldn't do that sort of thing. So is it going to be difficult? Absolutely. It's going to be a whale of a challenge, probably bigger than any of those other. But is it doable? Yes, it is doable. And when you ask yourself that question, I ask you to also ask yourself another question. Why should I work to combat climate change? And on a personal level, I'm answering that question for me with a picture for you to see. Those two on the right, particularly this young lady and this young man that looks like Grizzly Adams, these are our children. And that is why I work to combat climate change, because I want them and their as yet unborn children to have a world similar to what I have had the privilege to be in. And they are the reason that I do everything I can and talk whenever I can about climate change. And as we wrap up the slides, I want to convey once again that climate change is simple because it's well understood science that goes back to the 1800s. It's serious because the impacts are already being felt and they will only accelerate from here, but it's solvable. We have what we need to make change. What we need forward to moving forward is the dedication to make the change that we know we need to make. I want to give special thanks to Scott Denning at the Colorado State University, great guy who helped come up with the framing Simple, Serious, and Solvable and helped come up with some of these slides. I appreciate his efforts very much. And before I put up my last slide and start to take some of your questions, I want to make a very defined change here. I have been talking about facts and science, and this next slide addresses what was almost always the first question I got. People ask me, what can I do? So rather than wait for that question and try to answer it verbally, I produced a slide to answer the question for you. And these are 10 things that you can do to help battle climate change. Now, the reason I point out the difference is that whenever you start talking about things that can be done and changes that can be made, there's subjectivity, and by definition, there's policy involved. My undergraduate majors were atmospheric science and political science. I understand there's a difference here when you talk about what a person can do, but I show you this because it's important, because everybody asked me the question. So I'll go through them very briefly and then open it up to the questions this evening. So the first one is first for a reason. Talk about climate change. The most important thing, in my opinion, that any of us can do is talk about climate change. You don't have to have fancy graphics and information that confuses people, although I hope it didn't confuse that much. You can start talking about climate change by just talking about how things seem to have changed and what you've noticed, and does it seem weird, and have you noticed that? That's all you need. That's all you need to start talking to anybody. A survey came out recently, said only 1 in 3 Americans ever talk about climate change, even though close to 80% are concerned about it. Only 1 in 3 ever talk about it. The person standing next to you at the grocery store, in the line at the bank, or wherever you happen to be, that person might have concerns just like you, but we don't talk to each other about it. Let's start to change that. One-on-one conversations can make tremendous differences. I'm talking to you tonight out of that same sort of philosophy, that it's important to start by talking. So that I would encourage you to do. Number 2, plant trees. I already talked about it. A little hard to do in January. It won't be long before the ground thaws. It's a great thing to do. If you fly, you can either perhaps fly less, or you can purchase carbon allowances. You see there's a website on the screen that I think is a great resource. That particular nonprofit does a great job of taking carbon out of the atmosphere by virtue of using the donations that they get. You can research it yourself. I suggest that you do. And by the way, if you want to hang on to these while the slide, because the slide will go away in a bit, you can just screenshot this. I encourage you to do that if you'd like to screenshot this screen. Number 4, eat less meat and dairy. Try for locally produced food. It makes for fewer greenhouse gas emissions for sure. Leave the car at home. I put the save money in the parentheses because what's better than helping the environment with climate change and also saving money? The more you can leave the car at home, the more money you save, obviously. Reduce your energy use in all your consumptions. Not suggesting that you need to live in a cold house with the lights off all the time. That is not necessary, but any reduction makes a difference and saves money. Invest responsibly. Those that have the money to invest can do so with climate change in mind. Cutting consumption and waste also saves money. If you want to join a local group and get more involved, just my suggestion is go to Google, type in Michigan Groups Tackle Climate Change. You'll get all sorts of choices. You can even put in your own particular area. But if you put in that sort of a search, you'll get a lot of ideas that might work for you. And obviously vote with climate change in mind, which November was our best chance, but we'll have another chance before long. At the very bottom of this slide is contact information. When we finish question and answers, you might still have a question for me. You can reach me at that email address or on Twitter at Chris Edwards TV. So with that being said, Uma, I think I'm going to open it up for questions. I'm going to start in the chat and read these questions that are in the chat, and I'm reading them cold. So
there's only one question answer feature. How can using electric cars, etc., help when on a pie chart it was responsible for half a quarter of global warming? See our chart or something.
Right. So that's a great question, and I'm glad that you asked it, because here's the thing. If you use an electric car, if you buy an EV and you use it, but you're charging it with a source that is not renewable, then it's not making much difference at all. Absolutely true. So the key is twofold. It's first of all to use an electric car, because an electric car, number one, you know that EV is not putting out any greenhouse gas emissions as you drive it. because it doesn't have an internal combustion engine. So you know you've taken it out of that. But again, if you then charge it up by using electricity, which is generated purely with greenhouse gases, you haven't made much of a difference. Absolutely true. But the grid is cleaner than internal combustion engines. Here's what I mean by that. Across the entire country, more than almost 25% of electricity in the United States is generated from renewable energy already, and that number is going up all the time. So right off the bat, you've got 25% that's reduced. You also have approximately 20% of it that comes from nuclear energy, which does not produce greenhouse gases. And then you get into the share, 40%, that's natural gas, does produce GHG, greenhouse gases, but not as much as coal. And then that last 20%, or a little less than 20%, is coal, which is the dirtiest, if you will, of the choices. But even if you have half the grid or even a third of the grid that's renewable, you're making a significant difference. And the cleaner we make the grid as time goes on, because that's what's going on, the grid is getting more and more renewable and less carbon-based, then that EV does more and more positive things as it moves through its lifespan. The country, the grid is much, much more renewable than it is nationally and than it is here. Here in Michigan, by the way, just to give you a rough idea, because this is where we live and love, our current mix is 33% coal. That's kind of a large number. It's the largest single source. It's 30% nuclear. Again, no greenhouse gases from nuclear. It's 27% natural gas, and it's 10% renewable. We want to get that last number up. We want to get that first number, coal, down. That is the direction in which we are moving. And the more quickly and the more solidly we do that, the more benefit that comes from that EV when you plug it in. So thank you for asking, Anonymous. I appreciate the question.
Yeah, thank you. And I don't see any other questions here, Chris. But we got a very positive comments about the presentation. It was wonderful presentation and fabulous and excellent information, very educational and very informative. And also, by the way, anyway, I have an electric car.
Oh, you do? Excellent. Yes. Excellent. Thank you, Uma. I appreciate that. Those that are still with us, and I see we still have most of the participants here. If you come up with a question, I don't have to run off right at this moment, so you can let things ruminate for a bit if you'd like. Also know that I will be doing another presentation and unfortunately, I don't remember right off the top of my head when it is. Uma,
March 22nd.
March 22nd.
Okay. March 22nd, Wednesday. Chris is going to be in person at CMPL. So you all can attend and register for the program and attend, and in person, you can have any questions if you have in mind. And please ask him, and you can have in-person questions. And so you can meet with him and have conversation with him in person. And so I hope we...
Yeah, I'm sorry. I look forward to that very much, and I hope there will be less snow on the ground on that day. I predict that there probably will be less snow on the ground today. But yeah, I will be changing some elements of the presentation. But the thrust of climate change is obviously not going to change much in the next couple of months. But if questions come up between now and then you'll have an opportunity then to meet me in person, and we can talk about these things in person. But I do want to, before I leave you, I do want to make it clear that the obstacles for combating climate change, the obstacles to the solvable part of this, are not technological. The obstacles are not physical. The obstacles that we have remaining in front of us are political. And by that, what I mean is we have to decide as a society to make the changes. And the first step in that is understanding what the challenges are and understanding what the solutions can be. And that's part of what this evening's been about. And that's part of why I'm so thrilled that those of you that chose to attend have learned from that. But it really is a three-pronged approach that is going to make change happen. The first is the individual, and that obviously is each of us, the one we stare at when we look in the mirror each day. Individual change along the lines of what I'm showing you on the 10 things that you can do. Hugely important, no doubt about it, but it's only one part, if you will, of a three-pronged stool, because that individual is a good place to start. But don't think and don't be made to feel guilty that your individual actions are the entire thing, because they're not. They're the beginning of a change. We also, in addition to the individual, we need corporate change and we need governmental change. Now, we are very fortunate in our country because we live in a democracy where an individual can impact corporate behavior and governmental behavior by nature of our democracy and our capitalistic system. We can affect all three of those pillars of change, but make no mistake about it. I don't want to sugarcoat this. This level of change over the time frame we have is not going to happen without all three pillars, and an individual can get it started, and an individual can affect all three of those pillars.
Yeah, you're perfectly correct, Chris. I really take it. And I have a personal question. What is this about gas stoves? Are they creating any climate change? Gas stoves are not very, very good now recently. Having gas stoves at home.
Yes.
Yeah.
Thank you for the question, Uma, because it's been very much in the news lately. And I have dug into this and learned some more things myself. We used to have a gas stove. We don't anymore. We have an electric stove. But in a nutshell, recent studies have shown that gas stoves leak some natural gas into the area where they're being used. And in most people's houses, most people that have a gas stove, it's in their kitchen.
I have a gas stove. I have a gas stove too.
And unfortunately, some of the natural gas that powers your stove leaks into the environment around your house. Okay. Unfortunately, some of that natural gas, not only does it leak into your house, and there's the latest study that's gotten a lot of attention is showing that that is a not insignificant contributor to asthmatic problems, especially in children in homes where gas stoves exist. So that's some very attention-getting research, especially for anybody that has had an issue with asthma, anyone in a household. So that is concerning. But from the climate change standpoint, a lot of people don't realize that natural gas is about 80% methane. And remember, methane was one of those gases I told you about at the beginning that is a very potent greenhouse gas that we need to cut down on as quickly as possible, because that's the low-hanging fruit. We need to have less methane go into the atmosphere. And 80% of leaked natural gas is methane. And if we can convert that natural gas stove to an electric stove, you've done two things. You've made the indoor environment in that house safer and cleaner, and you've reduced the amount of greenhouse gas that goes into the atmosphere. So I am not saying, far be it from me to say, that you, Uma, or anybody else need to trash your gas stove immediately and get an electric stove. However, do know that that change will be positive for the environment and probably positive for your health. So that's something to consider as you move forward in time.
Okay, thank you. Thank you very much, Chris. We really appreciate and thank you very much. Looking forward to seeing you in person in March.
Thank you very much. Thank you. And again, I want to thank everybody for coming this evening, for being part of this. And thank you to the library for bringing me in and hosting me. I look very forward to being there in person on a warmer evening so that we can talk and continue the conversation at that point.
Thank you. Have a good night. Good night, everyone.